And now introducing Mr. Hildal and his awesome 8th grade math students. In the southwest corner of the Spokane Valley, today we'll be learning about transformations. Now just sit back and enjoy the show.
Thank you, Sierra, for that lovely introduction. Here we go. Fourth time's a charm. We have a new saying today. Okay, so the first one, a lot of you can learn a lot about congruent statements. This is something we haven't gone over a lot, but we've done in the past. And so what we want to notice is when we're looking at congruent statements, we want to notice what order they're in. Because in a congruent statement, whatever order they're in tells you what is congruent to which. Meaning, if we look at this, L is congruent to, and that little sign means congruent, L is congruent to N, right? So L and N should go first in this congruent statement. L and N should go first in this congruent statement. So let me just fix that there. L and N should go first. Okay? So we should have L and N first. So let's go ahead and put that. So since L and N are congruent, they're going to go first. What else is congruent? Well, these are both M. So M's going to go next. And then what else is congruent? P and O. So P and O. So notice that L and N are in the same position. M and N are in the same. M and M are in the same position. And P and O. So which one matches what we see up there? And that is B.
I got one more.
Okay. Notice here, this is saying that M and O, since they're both first, are corresponding, and M and O are not the same, nor are P and O. Well, actually, P and O are, but M and N are not. So that's why D is wrong. Okay. Number 2. Everything is congruent on this picture, but if you look closely, these sides are not congruent, so therefore, those are not congruent. Okay?
Yeah.
Everything else, corresponding parts are equal except for that one little part, so they're not congruent. Number 3, okay, again, what is congruent to C? What's congruent to C? G. Okay, so where are C and G in the same spot? Middle, good. C and G not in the same spot. C and G not in the same spot. C and G in the middle. Okay, now I go, is B congruent to F? Is B congruent to F? Notice the three marks right up here, Nico. Okay, so B and F are, and then B and E are not, so it's A. Okay, number 4, same dealio with the corresponding parts on the congruent statement. We want to find TV. TV is this segment right here. Notice it's first and last in that one. So that means it's congruent to QS, which is this one. And if QS is 6, then that means this is also 6. And that's therefore it's B. So the order tells you the corresponding parts. Okay? Angle U is corresponds, because that's in the middle, that corresponds with R. And if we're finding U, and we know that R is the third angle of a triangle that has 50 plus 1 plus 70 is 120, and I know it has to be a total of 180, so that has to be 60. So that means U is also 60. Okay? And number 6, it asks you to draw the lines of reflection, or the lines of symmetry. So the first thing we're going to do is draw those lines of symmetry. How many were there? How many were there, guys? 8. Nico says 8. What do you guys think?
4.
1, 2, 3, 4, 5, 6, 7, 8. There are 8. Way to be clutch there, Nico. Okay? There are 8 lines of symmetry. Okay? Now, here's where you guys really need to dial this in. Angles of rotation. Okay? Because here's the deal on this one. So I'm going to go ahead and take a picture of this. This could help you guys a lot. We did this in class, but some of you didn't quite master it. So let's master it now. So we're going to take a copy. We are going to copy and paste it. And go ahead and make it transparent like we usually do to be able to look at the rotational symmetry. So, okay. So then I'm going to put this over this. Because we're zoomed in to 125%, it's a little bigger, so we'll make it the right size. There we go. Okay, so watch closely. Starting point. Circles on the top, right? 1 rotation, they're congruent. 2 rotations, they're congruent. 3 rotations, they're congruent. 4 rotations, are we halfway there yet?
Yes, we are.
We've got 180 degrees, and we've already had 4 times when they're congruent, right? 4 turns. A 5th turn, a 6th turn, a 7th turn, and it took 8 turns, and we could turn it 8 times, and each time it was congruent, or locked in exactly the same. So the way we do this is just go 360 divided by 8, and we get 45 degrees.
Yep.
So what that means is, every time I turn it 45 degrees, it's going to be congruent. 45 degrees, and then another 45 degrees would put you at a total of what?
90.
90. So some of you didn't get that, some of you messed up on that, you just kept putting 45, but you have to keep adding it because it's going around in a circle all the way up to 360, 180, 225, 270, 315, and why do we not write 360? Everything goes 360. Don't write 360. Okay, so 8 rotations, but we only write 7 angles because we don't write 360. Got that? Any questions on that?
I got 100% on that.
Excellent.
I didn't.
Okay, number 7. We'll come back to 9 here in a minute. Number 7, we're looking, does it have line symmetry? Yes? How many lines?
1.
1. And it's this line right here.
Yeah.
Fold it in half over that line, it's a mirror image. Number 8. Number 8 is a cool problem, similar to the one we had on the an assignment in class, or the quiz. Is actually the quiz. So if I take a picture of this, I'm going to zoom out so we're at, it's going to be the same size, so I'm going to take a picture, and I'm going to copy and paste it. Well, actually, I'm just going to set the image transparency. And watch this. This is when it's really cool. We can go ahead and look at this, and we can see that we rotate it once, locked in, right? Congruent. Twice, congruent. 3 times, congruent. 4 times, congruent. We get around to a 5th rotation, and we're back to where we started. So what would I do to find the angles of rotation?
Divide 360 by 5.
Good, Jordan. 360 divided by 5, which is 72. So that means the angles of rotation are every 72 degrees. So does it, how many lines of symmetry? 0 or none. There is no line symmetry because of the curved nature of the pattern. And then this would be 72, 144, 216, 288, and that's it. So we don't write 360. Good job. Okay. Wait. Okay, write that down.
Wait.
Are you still recording?
Yep.
Is it on?
9. So what I did on the graphing ones,
Hi.
to save us a little time going over this, I went ahead and just took pictures of my answer key. So I'm just going to go ahead and put those up here. So this is what the graph should look like. Notice this here was my pre-image. And then notice how I connected my pre-image to the origin with a straight line because I had to rotate it 90 degrees clockwise about the origin. And then I rotated this 90 degrees. I traced it, rotated it until these 2 lines made a right angle. And that is the correct answer. Yes, Avery?
I rotated about the origin, but it didn't say to do that.
Yeah.
I know. I verbally told you guys that. But I made sure it said that on the actual test. Thank you.
What are the measurements?
That's okay, I got that
Thank you. That one I said you didn't have to write it down. Okay. All right, number 10.
Oh my God.
Number 10 should look like that.
Water break.
Okay, number 10 should look like that.
Oh, I got that wrong.
So let's go ahead and zoom in on that and figure out what in the world you did wrong. Okay. Since it has a scale factor of a half and it's centered at the origin, can we multiply each coordinate by the scale factor to get the new coordinates?
Yes.
Yes.
Yeah.
Okay.
Oh, I know what I did now. Just are you gonna put down the coordinates?
No, that was the one before was the only one. This one you have to, yeah. So notice if I go 0 times a half, I get 0. 3 times a half, 3 halves, and 1.5. 2 times a half, 1. 6 times a half, 3. 4 times a half, 2. 3 times a half, 1.5. Half times 2 is 1, and a half times 0 is 0. So if I graph those ordered pairs, then I get my dilated figure. Notice, please put the prime marks or you'll lose points, so we know which one is the image versus the pre-image. Okay, label your vertices and label them correctly. Questions on that?
No.
Okay. Next one. Turn the page. All right, so now we have the parallelogram, which should look like this. Voila. Okay. So this one got bigger or smaller?
Bigger.
Bigger, because the scale factor is 2, so I multiply everything by 2. So we get 2, 6, negative 4, 6, negative 2, 2, and 4, 2, when I multiply every coordinate pair by 2. Then I can graph those, and it's really simple. Since it's centered at the origin, I can multiply by the scale factor to get my new coordinates, and then I just graph those, make sure I include the prime marks on them, and label them, and whoop, there it is. I have the dilated shape. It looks same shape, different size, so I know I'm right.
Well, we hold on, don't go.
You should have been, just so you guys know, you should be writing this down as we go, so we don't have to stop and wait for you.
Well, I'm ready. Still on vision, no?
Oh, so you didn't do it at all.
Yeah.
Ah.
No.
Number 12 asks you to, all right, so this one, let's follow directions, shall we? First, we were supposed to reflect ABC over the y-axis. That's this one right here. So here's ABC, and we reflect it over the y-axis, and it goes there. Okay, when we did that, what happened to the coordinates? Well, if it went from 4, negative 2, so this right here is 4, negative 2, and it became negative 4, negative 2, right here, what changed? The x-coordinate changed what? Changed the sign, right? Changed signs. What happened to the y? The y stayed the same. Okay? Y stayed the same. What happens then when we reflect across the x-axis here to this one? Okay, this one it's the opposite, right? The y-coordinate changes signs, and the x stays the same. So that's what I wanted you right there. Okay? All right, so notice we did that reflection, and then you take that reflection and reflect it again. So make sure you do that right. It's exactly what it says in the directions. Okay, next one. You're asked to do this quadrilateral, which is here number 13, not 113, as you would look at that typo. Okay, so this is a translation. Notice when we translate, we can just apply this rule to each coordinate pair. 6 minus 1 is 5. Okay? 7 minus 4 is 3. Negative 6 minus 1, negative 7. 8 minus 4, 4. 4 minus 1, 3. Negative 4 minus negative 4, or negative 4 minus 4 is negative 8. Negative 4 minus 1, negative 5. And negative 4 minus 4, negative 8. That to me is an easy way to write down the coordinates. As far as graphing it, I think it's pretty easy to go left 1, down 4, left 1, down 4, left 1, down 4, and left 1, down 4. Because that's all you're doing. X minus 1, Y minus 4. Okay? So translation's pretty simple.
Yeah.
12?
Help me.
Okay, number 14. This, by the way, these 3 problems will not be on the test.
Oh, thank you.
But these are problems you will see on the Smarter Balanced Assessment, so I thought they were really important to go over. Okay? So, first of all, remember one of our major points of emphasis was all three of our transformations, rotations, translations, and reflections, the shape stays congruent, right? Same shape, same size. The only time they change size is a what?
Dilation.
Dilation, good. Okay, so angle B and B prime have the same measure. True. We just said that, Cody. After a transformation, they're still going to be congruent.
Come on,
Okay?
Cody.
Just because they move, they're still congruent. Okay, is AC longer than side AC? No, they're the same. That's false. Is BC the same as BC? B prime, C prime? Yes. Okay. 15. Should look like that. Pretty simple. It's just a translation. It was 4 right and 3 up. 4 right, 3 up. 4 right, 3 up. Okay? All right. Next one. This is a really good problem. I almost guarantee you'll see this on the Smarter Belt assessment. In three transformations, can you get this and map it onto that? Well, what I would do is I'd rotate about this point first. 1. Rotation, right? Rotation. Nico, you can do that every time, but you still do it more than me. 2. I'm going to translate down 5 and over 1, right? So x minus 1 and y minus 5, translation. Okay, so actually over and down.
You're doing quite a bit today.
Okay, so then this would be here, right? And then in order to map it right onto that, if I reflect over the line x equals -1, then it would be exactly that. So those are the three. Now there are other, you could have done it in a different order, and there might have been something you did differently, but that's what I did. Rotation, translation, then a reflection. Okay? All right. Now on these.
Wait, can you go back? Wait, what about number P? Yeah, what about P?
Okay, so what I would write in this blank is rotate about point P.
Wait, can you just say
Dude, no one
rotation?
likes to see real high.
Well, rotate about point P 90 degrees clockwise would be the best. Okay?
What would you
And then I translate x minus 1, y minus 5, and then I would reflect over the line x equals -1. Like I said, this will not be on the test, but I wanted you to be, Burns and I want you to be exposed to it, so when you see it, you can go, oh, you know what, we did that in class, we can do this.
You can do it.
Mm-hmm.
Hey, so you should get
Like the
rid of
water
it.
line.
You go talking that line.
No.
It's not even on the
I didn't get that one right.
Okay, now, this is just reiterating that we can multiply the scale factor by our points and get our new points. So this is really pretty quick and easy one here. So we could do 3 times each of these, so it'd be -3, -3, 9, -15, -9, 0, -21, and -6. This one here, we're going to multiply by a fourth. Just to remind you, -8 times 1/4 is -2. -1 times 1/4 is -1/4. Okay, 4 times 1/4 is 1. 4 times -3 is -3/4. -1 times 1/4 is -1/4. 7 times 1/4 is 7/4 or 1 3/4. And -2 times 1/4 is -1/2. -2 times 1/4 is -1/2.
Is that on the test?
Yep.
That's what I knew.
Just multiply by fractions. I keep telling you guys, you need to go back and review that. Nah, multiply across top, across the bottom. Okay, number 19. Here's where you really need to hone in on, let me use my magic pen here for a minute. Here's where you really need to hone in on the prime marks here.
Wait, 1/4 25.
That didn't work. I'm not happy about that. Let's try this again. Maybe if I try a... Try this one more time. Okay, so see that prime mark.
Yeah.
that means it was already transformed. That means it was after the fact. So did it get bigger or smaller? Smaller. This is the smaller one, guys. So it's a reduction. So this is how many units?
Oh, yeah.
This is 1 unit, and this is 2 units. So everything is half as big. So the scale factor is 1/2.
Oh, I got that right.
Or we could do new over old. Okay? We could do our new coordinates over our old coordinates. And 5, our new one is 2.5. Our old b is 5, and 2.5 over 5 reduces to 1/2. You can always find scale factor by putting new over old. All right. With these ones get pretty easy here. This is obviously a slide to get from A to B. This one is definitely a flip or reflection. So that would be B. The next one is a turn, so we're going to rotate 90 degrees. The next one is a slide, then a reflection. So which one do you see up here? Reflection by a translation, so you can reflect first, then slide. Okay, so that one's C. Everybody see that one? Okay, and then on the other side, we have this guy here. This one, if you slide it down, then it's going to be like this. And then when I rotate it 180 degrees, it's going to be like that. So it would be a translation followed by a rotation. Okay? So translation followed by a rotation, B. 25. This one could be a turn and then a translation. 24 was B. 25, rotation and a translation, A. Hey, saxophones.
No.
26. This got determine if these are similar. So ABC can be mapped onto FGH by a slide and then a dilation, right? Or a translation followed by a dilation, C. Okay, number 27. This is going to be a flip and a dilation, right? So a reflection and a dilation, A. All right. Hey.
Dude, I got all those right.
Dude, way to go. All right, 28. The dashed line is the image. This is the pre-image. This is the image. So did this get bigger or smaller? Bigger. Notice these are each 2. So if this is 4 units and this one is 8 units, or excuse me, this right here is, that's wrong. You need to look at corresponding parts. This is 4 units and this is 12 units. How many times bigger is that? 3 times bigger.
Heck yeah.
Okay. Same here, but it's got smaller, right? If this is 2, 4, 6, 8, 10, 12 units, and this is 2, 4, 6, it was reduced in half. These guys are making me talk over them. I'm losing my voice.
Okay, bonus.
Worked out, didn't drink enough water. Okay. Lastly, okay. Now we have to look at corresponding parts. The height of this triangle is 114. So height over height equals hypotenuse over hypotenuse. So I just set up a proportion of the similar triangles and just use my cross product rule. This times this divided by that. So what is 114 times 105 divided by 60? 114 times 105 divided by 60, 199.5. So that's how far it is from here to here, which is the distance from dock to dock, 199.5 feet.
How much was that? Wait,
No problem.
I'm making this one.
Yep. So if you missed 3 and got that one right, you missed 2. All right, great job. Now let's take the test.